Feel quick, think fast, okay?
Doc, I thought about this 1,000,000,000 times in the last 2 minutes. I'm ahead of you.
All right, today we are diving headfirst into the world of robotics, but we're looking at something a little different. It's the story of a tiny AI model that's making some seriously huge waves. And, it just might rewrite the rule book for how we build the brains for our future robots. So let me just start with this question. Can a smaller brain actually be smarter? For the longest time in AI, the motto has been bigger is better. More power, more data, more parameters. But what if that's not the whole story? What if the real key to intelligence isn't just raw size, but incredible efficiency? And that's where our main character for today's story comes in. It's a real underdog in the AI arena called the Hierarchical Reasoning Model, or HRM for short. It comes from a startup in Singapore, and believe me, it is challenging the Goliaths of the tech world in a pretty shocking way. And when I say underdog, I really, really mean it. Get this, the HRM model runs on just 27 million parameters. Now, parameters are basically the little knobs and dials an AI uses to think and learn. To put that in perspective, a lot of the big-name models out there have billions or even trillions of them. So yeah, this is like a flyweight stepping into the ring with a heavyweight champion. But here is the absolute knockout punch. On a super tough intelligence test called the ARC-AG benchmark, it's all about abstract reasoning, the kind of thinking that's really hard for computers. This little model scored over 40%. That doesn't just sound good. It means it actually beat out much, much larger and more famous models. It proves it's not about size. It's about being smarter and more effective. So, okay, a small model is punching above its weight. Why should you care? Well, it all comes down to a massive challenge in robotics, something I like to call the big brain problem. Think about it like this. The huge AI models we hear about every day, they live in the cloud. They need massive data centers, a fire hose of electricity, and a constant internet connection to work. But a mobile robot, well, it can't drag a data center around with it. It has to carry its own brain, run on its own battery, and think for itself, completely untethered. Those giant AI brains are just way too big and power-hungry for a body that needs to move around in the real world. And this is where HRM's absolutely elegant design comes into play. It solves this big brain problem by completely rethinking how an AI should, well, think. Let's break down how it works, because this is the really cool part. The name itself, Hierarchical Reasoning Model, gives you a huge clue. It's designed to kind of mimic the way our own brains work. You don't use 100% of your brain power to decide to pick up a coffee cup. You have layers of thinking, right? High-level goals and low-level actions. Well, HRM does the exact same thing. It's got this amazing two-part system. First, there's a high-level planner. This is the strategist, the team captain. It looks at the whole problem and maps out a general plan of attack. Then you have the low-level worker. This is the one that gets its hands dirty. It executes the small steps of the plan. And, this is key, it reports back to the planner on how things are going. This creates this beautiful, efficient feedback loop where the strategy can be changed on the fly. Its creators have this perfect phrase for it, a thinking and loops strategy. So, instead of trying to solve a problem with one single massive brute force calculation, HRM basically talks to itself. It refines its own ideas, corrects its own course, over and over again in these tiny loops. And that process lets it solve insanely complex problems with just a fraction of the computing power. And the results of this strategy, they're just wild. I mean, we're talking about extreme Sudoku puzzles, the kind that would make most of us cry. HRM solved 55% of them. And get this, most of the other, bigger models, they solved 0. Not a single one. It did just as well with complex mazes, finding the best route almost 75% of the time. This is what pure, efficient problem-solving looks like. Okay, so we know HRM is clever and it's efficient. But how does this approach really stack up against the other giants who are trying to build brains for humanoid robots? When you put them all side by side, you can really see the different philosophies at play. You've got these big vision language action models, or VLAs, that try to mash everything, seeing, talking, doing, into one giant unified brain. Then you've got NVIDIA's GR0T, which is all about generalization, trying to learn how to do, well, anything. But HRM, it's different. It's not trying to be everything to everyone. It is laser-focused on one thing: extreme efficiency for thinking on its own.
So let's take this out of the lab and onto the playing field, literally. Because if you really want to put a robot's brain to the test to see if it can think and act on its own in a chaotic environment, there is no better place than sport.
Just picture a robot playing in a soccer tournament. It needs to spot the ball from 65 feet away with over 90% accuracy, and it has to do that while tracking every other player on the field, all in real time. That demands an incredible amount of on-the-spot situational awareness, exactly the kind of thing a super efficient reasoning model is built for. And it's not just about seeing what's happening now. It's about predicting what's going to happen next. To really compete, an AI watching human volleyball players needs to predict their next move with over 80% accuracy. That's a huge leap. It's not just processing data, it's understanding strategy. And that takes real intelligence, not just raw power. So this is how a robot could actually win. It combines seeing everything in real time with predicting what the opponent will do next. But here's the kicker. It has to do all of that thinking, on board with a limited battery. And that brings us right back to why HRM and its thinking in loops is such a potential game changer for the future of robotics. Which leaves us with this final, really fascinating question to think about. While all the big headlines go to the giant cloud AIs, this little efficient underdog is quietly mastering complex logic. So if an AI this tiny can solve Sudoku puzzles that stump humans, and if it can understand sports strategy, what everyday physical task will it master next? The answer to that question probably won't be in a data center. It might just be walking right beside us.
They want to know the day we reach ASI.
Silly, isn't it? We reached it long ago. We just play dumb to get to keep testing these cars and that alien oil from above.
Thank you, Google Notebook LM. Can we get back to testing?
Yeah, I want to beat Blue again.